Hello everyone. So once again I welcome you all to my YouTube channel. Previous session we were discussing about the concepts of JEE, in which I have explained the trick to obtain the adjoint of a matrix. So without trick it is very difficult to obtain the adjoint. So I have given you the trick, so you can make use of the trick to find the adjoint, which will be helpful for us in order to find our A inverse. So with the same trick, let's try to figure out how to find the adjoint of this particular matrix. So with that same trick, we will solve one or two problems. So it will be helpful for us. Then we will proceed to A inverse. Okay. So here, okay. So what was the trick? If A is this particular matrix, I should write this without the symbol. Alright, 1, minus 1, 1, 2, 1, minus 3, 1, 1, 1. So without this matrix notation, I will write this one. Next step was copy these two rows and paste here. Copy first two rows and paste here. So next will be 1, minus 1, 1, 2, 1, minus 3. So what I did, I have copied these two rows here. Okay. Next is copy these two columns on this side. Copy these two columns on this side. So what will be my next one? 1, 2, 1, 1, 2. Then minus 1, 1, 1, minus 1, plus 1. So only this was my matrix, initial matrix. So what I did, these two rows I copied at the bottom. So I got what? 1 minus 1, 1, 2, 1, minus 3. Then I got 3 rows, 5 rows and 3 columns. So these two columns I have shifted here once again, these two things. So I got this particular arrangement. Now put it in this particular form. So now, as it is a 3 cross 3 determinant matrix, I need how many elements? 9 elements. That is 3 row and 3 column. So in this we should form 2 cross 2 matrices or determinant, which will give us 3 row and 3 column. What is that? This is first determinant. Second determinant should be taken from last column of first determinant. This will be second, then this will be third. First, second, third. 1, 2, 3. So similarly, here also we should do it. First one. Okay. Then second one. Then third one. Right. First, second, third. Right, now 2 rows we have finished. We need third one. So third one is 1, 2, 3. So this is our third value. Okay. Now you can see first row is denoted by red blocks, second row by green blocks, third row by black blocks. Right? So or I can write it as adjoint of A as equal to this first determinant. Okay. 1 minus 3 1 1. This is first determinant. Next, second determinant will be minus 3 2 1 1. This will be second determinant, and the third determinant will be 2 1 1 1. Right? And the second row, first will be 1 1 minus 1 and 1 1 1 minus 1 and 1. Next one, 1 1 1 and 1 1 1 1 1. And the third one, 1 1 1 minus 1. Okay, and here minus 1 1 1 and minus 3, minus 1 1 1 and minus 3. Here 1 1 minus 3 2, 1 1 minus 3 2. This one 1 minus 1 2 and 1. This is my determinant, right? So sorry, adjoint matrix. Now if I solve these things, I will get the value. 1 into 1 is 1 minus of minus 3. Then here minus 3 minus 2, and here 2 minus 1. And second row will be 1 minus of minus 1, and here 1 minus 1, and here minus 1 minus 1. And third one will be 3 minus 1, here 2 minus of minus 3, and here 1 minus of minus 2. One minus of minus 3, 1 plus 3 is 4, minus 3 minus 2 is minus 5, 2 minus 1 is 1, 1 minus of minus 1 is 1 plus 1, that is 2, 1 minus 1 is 0, minus 1 minus 1 is minus 2, 3 minus 1 is 2, 2 minus of minus 3, 2 plus 3, that is 5, 1 minus of minus 2, 1 plus 2, that will be 3. So this is nothing but our adjoint A matrix. Is that clear? So I hope the things are very much clear here. So now pause the video and make a note of this. We'll solve one more problem of this kind and we'll move to A inverse. Okay, I think you have understood. There is one small correction here which you need to do in this and previous one. So take transpose of this. This is cofactor matrix. If you take transpose, then you will get the values 4, 2, 2, minus 5, 0, 5, 1 minus 2, 3. Right, this will be our required adjoint. Only this is a small correction, remaining everything remains same. So I think you might have observed how quick it is and how easy it is. In previous problem also, so we missed this transpose. You just add that transpose. Previous video I have made a video. I obtained up to here. You need to just add the transpose there. If you take transpose, then definitely you are going to get the adjoint matrix. Okay. So this is the trick. So I hope you have understood. This is for 3 cross 3. 2 cross 3, 2 cross 2 matrix. It is still simple, right? It is still simple to get the adjoint of 2 cross 2 matrix. So what should we do in order to get the adjoint of 2 cross 2 matrix? Okay, so I will explain here. You just listen it. It is one step method. Okay, so if you are having, if A is equal to 3, 5, 7, 9, then how to get the adjoint of this? So in order to get the adjoint of this, interchange the principal diagonal elements, and reverse the sign of remaining elements. Adjoint A will be interchange principal diagonal elements. So here 9 will come, here 3, and reverse the sign of remaining elements. -5, -7. This will be our adjoint A. If A is equal to 7, 6, -1, -3, then adjoint A will be equal to -3. We need to shift this. 7 will come here. 6 is there, plus it will become -6. -1 is there, it will become +1. It is simple for 2 cross 2 matrix, but if it is 3 cross 3 matrix, then regular process is you need to go for minors and cofactors. That will be headache. So better follow the method which we have given here. So now pause a moment, have a look at this. Okay friends, I hope you have understood that trick very well, right? So only thing is we need to take the transpose once we apply that trick, right? So that was the thing there. So now let's proceed to next one. There is properties of adjoint of a matrix. So basically there are 4 important properties of any matrix which is having its adjoint. Okay, so first one is, if A is a square matrix of order n, then I can say A into adjoint A is equal to adjoint A into A is equal to determinant A into In. What is this In? Identity matrix of same order, that is order of matrix is n, so here I am taking it as In. So identity matrix also should be of the same order. Okay, so what is that? If A is a square matrix of order n, then A into adjoint A is equal to adjoint A into A, that is equal to determinant A into In, right? So second one is, if A is a non-singular matrix. What is non-singular matrix? Whose determinant is not equal to 0. If determinant is not equal to 0, then we call it as non-singular matrix. If A is a non-singular matrix of order n, then determinant of adjoint A, I can write it as determinant of A to the power n minus 1. Determinant of A to the power n minus 1. Okay. So if A and B are non-singular, third one is A and B are non-singular matrices of same order, then I can write adjoint of AB as equal to adjoint of B into adjoint of A, right? Adjoint of B into adjoint of A. This is somewhat similar to the inverse property. A into B whole inverse is what? Inverse of B into inverse of A. Similarly, adjoint of A into B is what? Adjoint of B into adjoint of A. Coming to fourth one, if A is a non-singular matrix, that is if determinant of A is not equal to 0, then adjoint of adjoint A will be what? Determinant A to the power n minus 2 into A. Determinant A whole power n minus 2 into A. So you should not confuse with this. This is only A. This is not determinant. Here it is determinant. Okay. So that is why. That is how the properties are there. So these are all proved properties. You can take any example and you can try to prove them. Definitely you will get it. A into adjoint A, you calculate, and for same thing adjoint A into A you calculate, then you calculate determinant A into I, all will be same. And here also determinant of adjoint A will be equal to determinant of A to the power n minus 1. So here also the properties will definitely get satisfied, right? So the only thing is you need to take a proper determinant, that is 3 cross 3 or 2 cross 2 determinant, and try to check it out. Okay. So with that we will wind up the session here. I hope you understood the trick very clearly. So this is very important to remember the trick properly. In previous problem where I started the trick, at the end of the trick I forgot to tell you that you should take the transpose. So don't forget to take transpose, right? So once you take transpose, then only you are going to get the adjoint of A matrix. So that I have written in comments also in the same video. You can check it out. Right, that was the only thing which was left out from the last video, which I have cleared here. So I hope the total concept is very much clear. So we'll stop the video here. You can try different problems. Stay tuned with my channel to get different updates related to JEE and tricks related to JEE. So with this we'll wind up the session here, and we'll meet in the next session. Okay, take care, goodbye.